This week, we're going to be discussing statistics, and we're going to, well, uh, we're going to cover a lot of ground from basically from univariate statistics like medium, standard deviation, and we're also going to deal with linear regression, which I don't know if that's part of statistics, but it certainly looks at how well you can predict the value of one property based on some other property. So you have some independent property that you're measuring, and you want to be able to predict some other property. So that's where we're going. We're going to start with the frequency histogram, because this is a good way of describing variability of a single parameter that's you're either measuring, or maybe it's an outcome from some manufacturing process. And as I mentioned before, well, univariate, or maybe I didn't, univariate statistics deals with essentially statistics of a single property or variable that's that you're measuring. Bivariate would be in that case a linear regression where you're measuring two properties. You're measuring one property and trying to predict a second property based on that. So we're gonna start with univariate statistics. So you can imagine case of an auto manufacturer. One of the things they worry about all the time are the gap, and you can see here the gap between two surfaces on a panel. For example, this might be the gap between the door and the door jamb, and you want that to be as small as possible, or you at least want it to be predictable, and that the variability would be reasonably small. So one of the things you could do is measure it and then tabulate the values. Now imagine that we have 7 cars and we measure 7 values, but imagine you have 100 values over 100 different cars. It gets difficult when you do that to really kind of understand the what actually is going on. What's going on with my data? So there are other approaches you might use, one of which would be just to create a bar chart of the individual values. In this case, you can see we have the 20 values along the horizontal axis. And then we have, on the vertical axis, we have the gap width. In other words, the width of that space between the door and the door jamb. Let's say it's measured in millimeters. You could measure each of those values, the first 20 values, and just record essentially what they are. So here we have 1.5 millimeters above 2 millimeters. Here's the value, and the fourth value is, around 0.6 millimeters. It's probably an improvement over a simple table, but we can do even better yet. So let's look at another technique that's frequently used. That is of the frequency histogram. To create a frequency histogram, you take all your values and then you throw them essentially into different, what are referred to as bins. So that's what we have here, the bin. In this case, we have one bin starting from all values less than 0.4. So my analogy of description of this is describing gaps. Kind of falls apart because we cannot have a negative gap, obviously. But this is some other measured value or property that we've recorded. So we have 0 values less than 0.4. And then we come to this bin here between negative 0.2 and 0. We have 1 value. And then you can see as we get into these more central values, say between 0.8 and 1, we have 33 values. And then it tails off when we get to higher values, say 2.2 to 2.4. We have only 1 value. So that's what this frequency column here in this case is showing. It's just the count within each of these ranges, or the number of instances within each of these ranges. So we can tabulate it like that. This is useful. But we can also then take this in the next step, which is to plot those bins, the frequencies, on a bar graph like this. So you can see between 0.8 and 1, we have about 32 values or 33 values. Here on the vertical axis are the number of instances, or actually the frequency of observations within each bin. So as we saw before, you have less number for the lower values, and then you get to this sort of central area where the values increase. And then as we get to the higher values, the number of frequency decreases. And this is what you're looking at is actually the realization of 200 sampled values from what's called a normal distribution, or frequently referred to as a bell curve. And it's referred to as a bell curve because it kind of has a sort of typical bell-like shape, like if you think of an old bell from the cathedral. It has that kind of a shape. And that's a very common frequency distribution that's observed in natural and engineered systems. All right, so that's a frequency histogram. You can also plot it as relative frequencies. So you see in this case, instead of the actual number of instances, we've plotted the number of instances divided by the total number of samples. So in this case, I just divided all those frequency values by 200. So these provide essentially, you can see, so for example, in this range between 0.8 and 1, you have a little bit more than 0.16 of the values fall within that range. So they give you an estimate of the probability of values falling within a specific range. All right, so we can look at different frequency, or in this case, relative frequency histograms for different, let's say this is the measured gap from one manufacturer and this is from another manufacturer. And the axes are essentially the same. They go from, let's pretend they only go from 0 to 2.6. So this, if you look at this one, then the gaps are essentially the central value, or the sort of middle value is about right here around 1.4. And in this case, the central value is around 1. So you would say, well, this manufacturing process is better than the manufacturing process that resulted in this frequency histogram. Frequently, that central value that we talk about, we'll just use the average value. It's closely related to this concept of accuracy. In other words, are we getting, if we're trying to hit, say 1 millimeter, then this is essentially telling me we're essentially doing that. We're getting pretty close to 1 meter. So it's related to accuracy as opposed to precision. Now, the other kind of property that you can really look at with the frequency histogram is how much they vary, how big the spread about that central value is. So in this case, I've switched back to a frequency histogram, and this goes from 0 to 60, or 0 to 70. And this one goes from 0 to 40. But you can see this one is essentially, I might say, fatter. In other words, the spread is wider than it is here. So these values, they're more, essentially, if this is our gap width, you might say that the manufacturing process is more precise because the values fall within a narrower range than they do here. So the confidence interval up here is smaller. And we can relate, we're going to talk about this later, we're going to talk about the standard deviation, which is some measure of that spread, or that about the central value, or that confidence interval that we've been talking about. Finally, you should be aware that not all distributions have that symmetric bell shape. You can have what you call a skewed distribution, which is essentially asymmetric. So in this case, it's not entirely clear where is the central value, where is the mean value in this kind of case. We'll talk about that in a future video or lecture video.